Okay, let's dive right into this. Welcome to today's Explainer, where we're heading straight to the whiteboard. We're going to transition your mindset today. We're moving away from building slow, CPU-bound charting tools, and we're stepping into the world of high-performance GPU-accelerated rendering using MQL5's DirectX capabilities. Look, if you've ever felt that frustration of a chart just completely freezing up under the weight of complex, real-time calculations, well, this is exactly the architectural leap you need to make. As a senior engineer looking over your architecture, I've broken our session down into 6 crucial areas. We're going to look at the big picture, cover the core DirectX concepts, map out professional usage and workflows, look at some real examples with 3D surfaces, go over the important APIs you need to know, and finally, we'll lock in on common mistakes and memory management.
So, part 1, the big picture. Let's start with a 10,000-foot view of why we even need to utilize the GPU in algorithmic trading.
Standard MQL5 objects, which rely on traditional GDI graphics processing, those are perfectly fine for a few arrows, maybe some text labels, or simple trend lines. But think about what happens when you're dealing with massive, complex data arrays. Say you're rendering thousands of data points on a custom volatility dashboard, and you're doing it on every single tick. That CPU bottleneck, it causes totally unacceptable chart freezes, mostly because standard rendering is heavily reliant on the main thread. And this is where DirectX becomes your absolute magic weapon. By utilizing it, you literally offload all of that heavy mathematical lifting straight to the GPU. This allows for high-performance, real-time visualizers that keep your trading terminal lightning fast and fully responsive.
All right, part 2, core DirectX concepts. Let's break down the foundational vocabulary of GPU rendering. Let's start with the DirectX context. I want you to think of the DirectX context as your physical art studio. It's the fundamental space where all your GPU operations are going to execute. You initialize this with the DXContextCreate function. And here's the thing. Without this environment, absolutely nothing else can exist. It manages your internal state, the resolution of your rendering area, and it gives you the infrastructure needed for your graphics hardware to actually communicate with your MQL5 trading app.
Now, if the context is your studio, shaders are kind of like the brilliant, hyper-fast artists working inside that studio. These are specialized programs that you compile using the DXContextCreate function, and they run directly on the GPU hardware. So instead of your CPU sitting there calculating how every single pixel should look sequentially, one by one, the shader does it in parallel. It works at lightning speed, processing your complex graphics and price geometry instantaneously.
And next up, you've got your raw materials, your buffers and textures, which you initialize via DXBufferCreate and DXTextureCreate, are basically the paint and canvas that you're feeding into your shaders. So a buffer might hold your vertex data, the actual 3D coordinates representing your market data, while a texture provides the visual skin or the color mapping. You absolutely must prep and load these materials into the GPU's memory before your shader can go to work.
Moving on to part 3, professional usage and workflows. Let's talk about the standard pipeline pros use to guarantee flawless execution.
Every successful DirectX operation strictly follows this 4-step lifecycle. Step 1, you initialize your studio with DXContextCreate. Step 2, you compile your artist, your shader, with DXShaderCreate. Step 3, you render the actual data to the screen using DXDraw. And step 4, and guys, this is absolutely critical, you clean it all up with DXRelease. Look, deviating from this pipeline or skipping steps, that is a guaranteed way of introduce fatal errors into your automated systems.
Let's hit part 4, real examples using 3D surfaces. How do we actually apply this inside the MetaTrader 5 terminal?
Well, for advanced custom visualizations, the CCanvas 3D class acts as your main graphical engine directly on the trading chart. It's fantastic because it beautifully bridges your standard MQL5 code with the underlying DirectX API. What this means for you is you can map out fully rendered 3D environments, complete with depth and perspective, without needing to sit there and write a low-level graphics engine completely from scratch. It handles a ton of the heavy lifting for you.
By manipulating control APIs like ambient color set, light direction set, and projection matrix get, you can totally transform how market data is perceived. Just imagine building a live, rotating 3D surface of options volatility across all sorts of different strikes and expirations. By dialing in ambient colors and tweaking light directions, you're giving structural depth to incredibly complex data matrices. This lets you spot market anomalies and volatility skews instantly, rather than squinting at a tangled mess of flat 2D lines. Okay, part 5, important APIs to know. Let's chunk the massive API list from Chapter 32 into a few digestible categories. We can separate your toolkit logically into 3 main areas. First up, your setup functions, like DXContextCreate and DXContextSetSize. These define the boundaries and the very existence of your workspace. Next are your data and I/O functions, like DXBufferCreate and DXInputSet. These are vital because they push your arrays of market data from the CPU over to the GPU. And finally, you have your execution APIs, primarily DXDraw and DXDrawIndexed, which actually pull the trigger and render your geometry right to the screen.
Now here is a crucial point. You have to explicitly link your buffers to your shaders using specific input functions, DXShaderInputSet and DXShaderTextureSet. Remember, your standard MQL5 CPU data and your GPU memory, they live in 2 completely different physical locations. These functions act as that secure bridge, mapping your inputs perfectly so the shader has the exact variables it needs right before you invoke that draw command.
Finally, Part 6, Common Mistakes and Memory Management. As a senior engineer, I really have to emphasize these pitfalls.
Listen to me on this. Making mistakes with hardware-accelerated memory isn't just a simple bug. It's a system-crashing cardinal sin. First pitfall, forgetting to align your struct memory properly. GPUs require data to be packed in very specific byte alignments, totally different from standard CPU memory. Second, losing track of active DX handle type objects as your program runs. But honestly, the absolute biggest mistake aspiring pros make is abandoning unreleased GPU memory. When you create buffers and shaders, they are eating up dedicated hardware resources. Failing to release them creates fatal memory leaks that will eventually freeze your entire terminal. And trust me, it usually happens right in the middle of your most profitable trade.
I literally cannot stress this enough. DX release is mandatory. Do not ever leave the studio without cleaning up your tools. You need to frame unreleased memory in your mind as a crash just waiting to happen. You have to explicitly call DX release for every single context, shader, buffer, and texture you create the second you're done with them, or when your EA shuts down. Flawless resource management, that is exactly what separates the professionals from the amateurs.
You are now equipped with the ultimate magic weapon to completely bypass CPU rendering limits. You understand the context, the shaders, the workflow, and you know the absolute necessity of strict memory management. The full power of the GPU is entirely at your disposal. So, I'll leave you with this. Now that you have these tools, what invisible market patterns are you going to render visible? Get out there, optimize your MQL5 code, and build something extraordinary.